We have another second order differential equation here. It's homogeneous since it's equal to 0 and nothing else. We have two initial conditions, so we have another initial value problem. So to solve this, the first thing we're going to have to do is set up the auxiliary equation, which will be m squared plus minus 2m plus 1 is equal to 0. So to factor this out, we're going to need two factors that multiply to be 1, positive 1, and those two factors must also add up to be negative 2. So looks like negative 1 will be that factor. So we have m minus 1 squared, so we have a perfect square here, is equal to 0. So this negative 1 has multiplicity 2. So and all that means is, we'll get down to that part later. So take the square root of both sides, m minus 1 is equal to 0, therefore m is equal to 1. Not plus minus 1, just 1. Alright, so from here, we can use that generic formula again, where y is equal to c e to the mx. So for y1, we have c1 e to the x, and y2 will not be c1 e to the x again, because they will not be linearly independent. So what you could do is use the reduction of order, which will be y of 2 is equal to u x times e to the x. But as Lapousse said, that won't be too necessary. We could just multiply. If we go through the whole process, we'll see that it's just the function itself times x. So x is equal to e, or c2x e to the x. Plug them into the Wronskian and you'll see that they are indeed linearly independent. So from here, put them together. The solution will be c1 e to the x plus c2x e to the x. All right, now for these initial conditions, y of 0 is equal to 4, y prime of 0 is equal to 0. So we see that there's a prime here, therefore we have to take the first derivative of this function. So we're going to get c1 e to the x plus c2, and then there's a product rule here. So we're going to get the derivative of the first times the second plus the first times the derivative of the second. All right. So from here, we're going to set, we're gonna do the first one. Y of 0 is equal to c1 e to the 0 plus c2 0, since there's an x there. So, and that is equal to 4. Therefore, c1 e to the 0 is just 1. So c1 is equal to 4. All right, and now the next one, y prime is 0. c1 e to the 0, which is just 1. So c1 plus c2 e to the 0, which is just 1, plus x, we have a 0 in there, so plus 0. And that is all equal to 0. All right. So from here, we have c1 plus c2 is equal to 0. So therefore, c1 is equal to negative c2. All right. And then, so we have c1, which is equal to 4. So therefore, c2, or actually c1 is equal to negative 4. It actually wouldn't really matter which one's which. So c1 is equal to 4. Therefore, c2 will be negative 4. So plug him at the end for the particular solution, and we'll get that 4e to the x minus 4x e to the x is the solution for this second order homogeneous differential equation.